जा रहे हैं एजेंटिक एआई का एक और नया चैप्टर। सो इसे हम लेक्चर वाइज डिस्कस कर रहे हैं, तो ये नेक्स्ट लेक्चर है। सो लेट्स स्टार्ट विद एजेंटिक एआई। सो एजेंटिक एआई इज द टाइप ऑफ एआई। सो इट इज द small part of artificial intelligence that can make decisions and take actions on its own. So it is fully based on automation without needing constant human supervision. So it is required very less human interventions. This capability is particularly valuable in intelligent automation and where agentic AI is used to streamline and improve various processes across different industries. So we have a different field where we can apply the agentic AI, and there are different domains like financial, banking, agriculture, education, and all. So there we can apply agentic AI. So this technical white paper explores several key areas. So technical details as in depth look at the technologies and algorithms that enable agentic AI to function autonomously. Overview of Agentic AI. So, a comprehensive introduction to the concept, including its characteristics and capabilities, real-time applications, example of how agentic AI is being used in the various industry to improve processes and outcomes, architectures. So, different structural design that support the development and deployment of agentic AI system. So architecture is based on the different structural designs. So development and deployment of the agentic AI system can happen. So techniques and frameworks. So methods and frameworks that guide the behavior and decision making processes of agentic AI. Security considerations. Strategies to ensure that agentic AI systems operate securely, protecting data and maintaining trust. Introduction. Agentic AI amplifies autonomy, flexibilities, and ability to make decisions in complex situations, including entirely unfamiliar domains. The new paradigm of hyper automation harnesses advanced technologies such as machine learning, robotics, and AI. In essence, agentic AI represents a significant advancement in artificial intelligence. It is categorized by its autonomous operations, environmental perceptions, decision making, and action executions to achieve specific goals. Agentic AI actively learn from the user interactions, behavioral patterns, and real-time data, improving its decision making over time in contrast to the classical AI which depends upon the presets, rules, and statistics dataset. So this abilities, goal and prior knowledge, observations and past based on that past experience, we take actions and based on environment. So agentic AI with environment, goal, learning and action. So this figure represent this one. Overview of agentic AI. So here we will start with agentic AI overview. So agentic AI can potentially revolutionize how tasks are executed in the software development life cycle. So what is the software development life cycle we will discuss in details. So here paint is there. We have paint. So like we have a software development life cycle. So like we have module, like some module is there, like module 1, module 2, module 3, and module 4. So this is the module 1, module 2, module 3, module 4. So we have 4 modules, and we are developing one by one in one life cycle pattern, and we can develop modules concurrently. So we can create a module like module 1 and then module 2, then module 3 and module 4. And we can also concurrently develop like module 1, 2, 3, 4 simultaneously. So this is based on that we have a different life cycle like waterfall model and some other software development lifecycle model is there. So based on the requirement, we choose the specific software development lifecycle based on how we create modules, how we create our software, like module wise or separate module wise or concurrent. So based on that, we choose the software development lifecycle. So in this process, in this process, it's crucial to understand what an agent is to grab an concept of agentic AI. An agent is a software program designed to perform a specific task. So agent is based on the specific task autonomously or semi-autonomously. It may be two types. So these agents perceive their environments, make decisions based on the predefined rules or learned pattern, and take actions to achieve their goals. Key characteristics of AI agent include autonomy. We last lecture we saw the diagram related to autonomy and reactivity, proactivity, and social ability. So you can check it out there also. I will explain here autonomy. So they operate independently, making decisions based on their protocols, rules, and learning. Reactivity. They respond to changes in their environment in real time. So proactivity. They take initiative to achieve their goals rather than just reacting to the stimuli. Social ability, they interact with other agents, humans, or external applications to complete tasks. Agentic AI is the built on the server several revolutionary principles. Agents operate independently, dividing and conquering complex workflows with minimal oversight. For example, imagine a smart thermostat with agentic AI capabilities. It can autonomously monitor your home temperatures and humidity level. So, detect any anomalies and contact the service provider to schedule maintenance or request a software update to optimize its performance. Agentic AI systems are capable of autonomously setting and achieving their own objectives. Like humans, these systems learn from their interactions, adapt to the new information, and continuously enhance their performance. So AI agents, for instance, may forecast consumer preferences by analyzing market patterns, which helps marketing teams better customize their ads. By learning from these patterns, the agent can adjust marketing strategies and optimize inventory management to meet the customer needs better. So, real world application of the agentic AI is healthcare domain. So agentic AI have a wide range of application across various industry. The first one we will discuss is the healthcare. So personalized treatment plan. With the help of agentic AI, we can plan for the specific patient and their treatment. So patient data and the recommended personalized treatment plans. Diagnostic support. Agentic AI assists in the diagnosis diseases by analyzing medical images and patient history, improving accuracy and efficiency. Customer service. The second one is the customer service. Workflow automation. Agentic AI handles routine tasks like onboarding, paperwork, and scheduling, allowing human agents to concentrate on the more intricate and innovative customer care activities. Cyber security. So real-time threat detections. Agentic AI system continuously monitor network traffic for the anomalies, detecting and responding to the potential threat in real time. Automated logistic. So we can change the logistic system. We can automate the logistic system through agentic AI. So logistics system equipped with agentic AI can optimize supply chain management, including the delivery planning. So this we can do that through agentic AI by factoring in the weather and the traffic conditions. These system automate real-time decision making processes to efficiently manage the flow of goods from the warehouse to delivery. This enhances customer satisfaction by reducing delivery times and ensuring precise delivery times. Autonomous decision making and adoptions. So, agentic AI is a type of AI that can set and follow its own goals without much help from humans. It uses sensors to understand what around it, processes the informations, makes decisions using algorithms, and then acts to change its environment. Autonomous decision making. So, what is the automation? Autonomous decision making. So, agentic AI systems are designed to make decisions independently. They are capable of doing that one without requiring continuous human input. The key process are their perceptions, analysis, decision, and execution. So AI system collect informations from the surrounding using the sensors, cameras or other input devices. Then they analyze. They process information to understand what happening, often using complex algorithm and machine learning techniques. Decision based on the analysis, the AI system consider different actions and choose the best one to reach their goals. Execution. The chosen action is performed automatically, whether driving a car, changing a manufacturing process, or answering a user questions. So, adaptive intelligence. Adaptations. Adaptations means the AI system can learn from the past experiences and the change behavior. This include the learning. AI system keep learning from what happened and update their methods and plans. Flexibility. It can change its actions based on the new informations or different situations to perform well in the changing environments. Optimizations. Over time the system improve how it makes decisions, becoming more efficient and effective. Architectures and the techniques in autonomous AI. Architecture and the techniques in autonomous AI. So we have an architecture and techniques in autonomous AI. Agentic AI architecture and techniques are important for creating AI systems that can independently make decisions and change their behavior. Examples are LangChain. So this combines large language model with tools and prompts to handle complex tasks using natural language processing. Microsoft semantic kernels. This helps create AI systems that can interact with external resources or API, allowing them to do many tasks independently. Auto GPT. This automate the creation and management of AI systems, making it easier to deploy and scale autonomous AI through Auto GPT. So LangChain, through this we can combine the LML with tools and prompts to handle complex tasks. The second one is the Microsoft. This help semantic kernel creates AI system that can interact with the external resource or API. So machine learning for the agents. Machine learning lets AI system learn from their experience on their own. So in machine learning, agents are capable of learning through experience by training models with lot of data to find patterns, and it's all about data. Machine learning is all about data and the learning through the experience with the help of data. Machine learning allows AI to make decisions without needing humans. These are the three main type of machine learning models. We have the three type of machine learning models: supervised learning, unsupervised learning, and reinforcement learning. So in detail, you can also watch my separate video of machine learning. There I explained the supervised learning, unsupervised learning, and reinforcement learning. Here we are using the graphical representation. So these models use labeled data. They are using the labeled data set. Here the labeled data set is like apple, orange have different format. Apple have different format and orange have a different format, which means the data has no answer. It matches input to the output, so the model can predict the answer for the new or unseen data. So it uses their training and predictions and test data. They give the output simple apple and orange, like detecting spam, recognizing image, and predicting patient medical conditions. In unsupervised learning, in unsupervised learning, uh, like we take the rough data or raw data. With the help of algorithm, we can separate the each specific colors in a separate modules or part. So it's look for the hidden patterns in data that haven't seen labeled. This means the model is trained in the data without predefined categories. The algorithm find patterns and relationship by itself. So algorithm have capability to find the patterns and the relationships by itself. One example is the clustering, where the algorithm groups similar data point together. So here a rectangle is there, here this triangle is there, and circle there. So they are capable of grouping group similar type of data with the help of algorithm, which can be useful in the marketing. Unsupervised learning, this is the example of unsupervised learning, where we can group the similar type of data. Reinforcement learning, it teaches agent. Here you can also separate the things based on agent and environment. It teaches agent by giving reward for the good actions. The agents learn to make decisions by interacting with their surroundings and getting feedbacks from the environment. They follow certain rules or policies to decide what actions to take. Reinforcement learning in machine learning. Input raw data environment with agent and output. Reward, state, and best actions. selection of algorithm, reinforcement learning. So framework, I have a framework. AI agent can make decision on their own, but to ensure these decisions are consistent, predictable and ethical, it's important to create policies. Policies is like a set of guidelines that control and direct AI actions, making sure they align with the values and norms set by the people who design, develop or use the AI. Policy is very important. Help structure the AI system so it makes decisions and follows rules that meet expectations. Without policies, the AI might behave in undesirable ways, such as sharing personal information without permission or engaging in illegal or unethical activities. Type of policies is decision and rule based, making the policies framework and based policy framework. So decision making policy framework, this framework ensures that the AI actions with social and legal standards. It makes sure decisions are not biased by the factor like the race or age. So rule based policy framework, this framework consider predefined rules and objectives. It ensures the AI adheres to established rules but can still adapt based on the situation. Agentic AI architecture. So we have a single agent architecture and multi-agent architecture. When developer or architect build agentic AI system, they use different kind of structures, so which can be broadly classified into the two category. So first one is the major architecture, the second one is the minor architecture. This major architecture, this type is handle strategic task and act as the main controller of the system. This type of handle regular and everyday tasks. Single agent architecture, a single agent interact with the environment and there is no feedback required on the another agent's involvement. It is like it was created for the well-defined problem. Agent 1, single agent architecture. So in this single agent architecture, we have only one agent. Like this, agent 1 is there. Single agent architecture. In multi-agent architecture, we have multiple agents work together and they can coordinate and make the decision making. They are used for the task that require collaboration between the agent. So they have their own task for each agent and they can coordinate with each other. A real life use case of multi-agent system is in automated trading. So in trading, we can use a multi-agent architecture where multiple agents analyze market trends and execute trades based on the predefined strategies. These systems can outperform human traders by rapidly responding to the market changes and processing vast data. So here agent 1, 2 and 3 is there. They are coordinating with each other with their tasks. So reflection based architecture. We have the third type is also called the reflection based architecture. And these are the designed to improve their performance through iterative self-assessment and refinement. This approach evolves the agent generating an output reflecting on its quality and then refining it based on the self-criticism. Examples include text generation, code deployment, and problem solving. So, agent 1 is there. Human AI collaboration architecture is also there. So, there we can collaborate AI with humans. AI involves designing system where AI agents and humans work together. In first architecture, we learned the AI with single architecture, in multi-architecture, how they are interacting with each other, and in this human AI collaboration, AI agent with humans work together seamlessly to achieve complex goals. It facilitates automate routine tasks. So agent 1 and person is there. Agent 1 interacting with person 1. Agent 2 is interacting with this ladies, and three is interacting with this, and they are interacting with each other. With the help of this collaboration, we can achieve the task. So some of the minor architecture are the below. So here are the some minor architectures are below. So first one is behavior based architecture. These agents follow set rules and react to the specific triggers from their surroundings. They cannot remember or learn new things but work well in suitable and predictable situations. For example, a basic chatbot is there that gives presets answer based on what user type. Deliberative agent. So make decision using a model of words. They plan their action by thinking about the future situations and results. This type of architecture is good for the complex tasks. So this deliberative agent are the good for the complex tasks that need a strategic thinking like planning routes for the self-driving car. So this is the deliberative agent. So we have the behavior based architecture, deliberative agent and collaborative agent. So collaborative agent work together to reach a common goal. They talk to each other and share the information to coordinate their actions. For example, a group of drones in a search and rescue missions where each drones cover a different area and share what it find with the others. Learning agents improve their performance over time by learning from their experiences. They use methods like reinforcement learning to change their behavior based on the feedback from their surroundings. For example, a recommendation system that tailors suggestions based on the what user do. Tools and technologies. Software and hardware requirement. Several developing tools and framework for agentic AI are based being developed. Most expand on the current Gen AI capabilities such as RAGE and large language model. So Lang graph is there, AutoGen, Crew AI, and Lamardex is there. So these are the framework. So in LangGraph is the orchestrations framework from the LangChain that allow us to build agentic workflow using the LangChain framework. AutoGen is a framework from Microsoft that allow building multi-agent conversations. Crew AI is the platform to build agents and multi-agent systems. Lamel Dex also has an agent framework for building agentic AI applications. In addition, Amazon's Bedrock's Vertex AI and Azure OpenAI have agent builder tools, deployment modules, and runtime. The second one is security and robustness. Security is a major concern when deploying agentic AI system without human monitoring or control. This approach has both benefits and challenges. Here are some of the challenges: handling unpredictable user inputs. AI agents must deal with the various user input which can be predictable, especially when involving multiple steps. For example, a smart home system might face a situation where multiple families members adjust the thermostat, lighting, and the security system settings simultaneously using different devices. Without proper security measures, this could lead to conflict and potential exposure of the personal data. Developers need to anticipate these risks and create strong security system to handle such scenarios. Interacting with the untrusted external entities. AI agents often interact with the external entities like other systems, humans, and data sources. These entities may not always be trustworthy, posing risks like data breaches and manipulations. Implementing strong security measures such as encryptions, authentication, and authorization is crucial for the protect communications between agents and external entities. And the functioning in the varied environments. AI agents operate in the various unpredictable environments which can introduce new security risks. When agents encounter scenarios they were not especially designed or trained for it can lead to security breaches. Ensuring that agents can adapt to diverse environments is essential for the maintaining security. One important area of the advancement is predictive maintenance and assets management. So governance integration is there. So embedding governance into agentic AI system is not just best practice, it is the necessity as these systems operate autonomously across various domains, making decisions and taking actions that can significantly impact business operations, customer experience, and regulatory compliance. Governance becomes essential. Therefore, having well-defined policies and oversight is mandatory. Legal and ethical boundaries agentic AI must operate within clearly defined legal framework and ethical standards. These include data privacy, protection, regulatory compliance, bias mitigation, and the fairness, auditability of decisions like implementing audit trials, and observability for every agent action. Fallback mechanism when confidence thresholds are not met. Cross-function governance must span across business, IT, and complex team that share tech. Google Cloud Agentic AI solution discusses how AI agents are transforming workflows across HR, manufacturing, and finance, and how governance challenges like data security and privacy must be addressed at each layer. So internal custom is there, a standard that can help strengthen agentic AI system include risk mapping, human oversight, governance integrations, monitoring systems. So these identify and classify risks that are specific to the autonomous agent. Human oversight is there that clearly defines situations where human involvement is required. So governance integration is there, make sure agentic AI system are aligned with the organization overall AI governance policies, and monitoring systems set up tools to track agents' behavior in the real time and allow for the quick reversal if needed. So this is all about agentic AI in this lecture. So if you like this lecture, you can like, share, or subscribe, and you can also interact with this lecture through comments. You can comment it so we can make the more agentic AI related videos, and we can learn together and we can grow together. So thank you for watching. So that's all from today's session. Jai Hind, Jai Bharat, goodbye.